An electric car is an automobile that is propelled by one or more electric motors, using energy stored in rechargeable batteries. The first practical electric cars were produced in the 1880s. In this picture you can see the diagram for an EV. Notice how every component is connected and to what. An electrical vehicle or an EV is an electrical motor, an inverter, a DC-DC converter, a battery management system or BMS, a charger, a battery pack, a 12-volt battery, a water pump, a vacuum pump, a display, a fuse panel with relays and a contactor and a fan controller. Before, the motors used in EVs were serial DC motors, although nowadays engineers have chosen to move from DC motors to AC motors. The choice is made by companies that produce electric cars. Tesla's Model S is using induction motors or the asynchronous motors, in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. Other brands, like Nissan, Chevrolet, or even Tesla Model 3 have chosen the permanent magnet motor because those motors are more efficient than induction motor or motors with field windings for certain high-efficiency applications such as electric vehicles. Tesla's chief motor designer was quoted discussing these advantages, saying, "It's well known that permanent magnet machines have the benefit of pre-excitation from the magnets, and therefore you have some efficiency benefit for that. Induction machines have perfect flux regulation, and therefore you can optimize your efficiency. Both make sense for variable speed drive single gear transmission as the drive units of the cars. So, as you know, our Model 3 is a permanent magnet machine now. This is because for the specification of the performance and efficiency, the permanent magnet machine better solved our cost minimization function, and it was optimal for the range and performance target. Quantitatively, the difference is what drives the future of the machine, and it's a trade-off between motor cost, range and battery cost that is determining which technology will be used in the future." An inverter is a device that converts DC power to the AC power used in an electric vehicle motor. The inverter can change the speed at which the motor rotates by adjusting the frequency of the alternating current. It can also increase or decrease the power or torque of the motor by adjusting the amplitude of the signal. While DC-DC converters can be based on a number of different designs, the underlying function remains the same. We might be talking about a step-up converter, which turns a low-voltage input into a high-voltage output, or a step-down converter, which does the opposite. The batteries of an electric vehicle typically output several hundred volts of DC. The electric components inside the vehicle, however, vary in their voltage requirements, with most running on a much lower voltage. This includes the radio, dashboard readouts, air conditioning, and inbuilt computers and displays. A battery management system, BMS, is any electronic system that manages a rechargeable battery cell or battery pack, such as by protecting the battery from operating outside its safe operating area, monitoring its state, calculating secondary data, reporting that data, controlling its environment, authenticating it and/or balancing it. The BMS will also control the recharging of the battery by redirecting the recovered energy, that is from regenerative braking, back into the battery pack, typically composed of a few batteries, each composed of a few cells. Various methods exist for recharging the batteries of electric cars. Currently, the largest concern surrounding electric vehicle transportation is the total travel range available before the need to charge. The longest range recorded to date was 606.2 miles, achieved by a Tesla Model 3. Fast charging is the process of a battery charging and discharging involves lithium ions from a positive electrode passing through a separator electrolyte. The ions then transfer, via a solid electrolyte interface (SEI), and intercalate into the negative electrode. The potential negative impact for rapid charging is that battery aging may be accelerated by the unstable SEI, produced by charging and discharging multiple times. An electric vehicle battery, EVB, also known as a traction battery, is a battery used to power the electric motors of a battery electric vehicle, BEV, or hybrid electric vehicle, HEV. These batteries are usually rechargeable secondary batteries and are typically lithium-ion batteries. These batteries are specifically designed for a high ampere-hour or kilowatt-hour capacity. The most common battery type in modern electric vehicles are lithium-ion and lithium polymer because of their high energy density compared to their weight. Electric vehicles (EVs) are powered by a high-voltage electric vehicle battery, but they usually have an automotive battery as well, so that they can use standard automotive accessories which are designed to run on 12 volts. They are often referred to as auxiliary batteries. Unlike conventional, internal combustion engine vehicles, EVs don't charge the auxiliary battery with an alternator. Instead, they use a DC to DC converter to step down the high voltage to the required float charge voltage, typically around 14 volts. If any of these systems overheat, damage is the result. So, to make sure these systems stay cool, EV manufacturers typically use liquid cooling. While air cooling could be used, it's not always practical. If the electric motor is mounted deep inside the vehicle, for example, it's difficult to route air to cool it. A vacuum pump is used in EVs for the same purpose like in petrol cars. It is usually required to ensure the availability of stable and effective braking power at all times. Usually, a good dashboard design facilitates safe steering experiences. The whole platform should be user-friendly and functional-rich. The electric vehicles (EVs) that share full states via electric signals. In electronics and electrical engineering, a fuse is an electrical safety device that operates to provide overcurrent protection of an electrical circuit. Its essential component is a metal wire or strip that melts when too much current flows through it, thereby stopping or interrupting the current. It is a sacrificial device. Once a fuse has operated, it is an open circuit. It must be replaced or rewired, depending on type. Electric vehicle relays and contactors, both large and small, are used throughout electric vehicles and come in assorted ratings for many and varied applications for remote control switching. A typical vehicle can have 20 relays or more. A fan is a powered machine used to create flow within a fluid, typically a gas, such as air. A fan consists of a rotating arrangement of vanes or blades, which act on the air. The rotating assembly of blades and hub is known as an impeller, rotor, or runner. Usually, it is contained within some form of housing or case. This may direct the airflow or increase safety by preventing objects from contacting the fan blades. Most fans are powered by electric motors, but other sources of power may be used, including hydraulic motors, hand cranks, and internal combustion engines. Thanks for watching. In the future videos I will make a parallel between electric vehicles and internal combustion cars. In that video I will talk about the values of pollution each method makes, the advantages and the disadvantages of each type. If you enjoyed the video, don't forget to like and subscribe for more.